Alright, Space Cadets. So today we're going to talk about the Space Transport System, or the Shuttle. Basically, STS, that one there is useful to know because every time you look at a mission for the Shuttle, it's known as STS, then mission number 20, STS 020, STS 137, etc. Alright, so basically by the end of this, you should be able to identify the different components of the shuttle, some limitations, and so forth, a few others. Now, propellants. How do you get it into space? This is an important part of any shuttle mission whatsoever. So you've got two sets of fuel. You've got these solid rocket boosters, the SRBs, and they are these bad guys here on the side, and they're pretty cool. So basically they're a pair of large solid propellant booster rockets, and basically once they're ignited they just go until they're burnt. About 2 minutes after takeoff they are jettisoned, which means dropped, and this is when they've used up their fuel. There's no point carrying them any longer, they're just going to slow you down. So basically they're then parachuted back to Earth, and once they're collected and repurposed and reused, which is pretty cool. So that's one of the places where we reuse it. But the shuttle is most well known because, became the choice, the one they wanted because it's largely reusable. The external tank's not, but it's the solid rocket boosters and the shuttle itself, the orbiter, are reusable. Alright, so basically these SRBs, we need those to escape Earth's gravity. On re-entry, essentially the orbiters falling to Earth or gliding, so falling with style, so it's not necessary to have the SRBs, you only need them to get out of Earth. You've got the external tank, so this is where we keep the liquid hydrogen fuel, and so that's the fuel, and the oxidizer, the liquid oxygen, for the main engines, which are just down here. So they're the main engines, and that's the fuel for that, that's the fuel tank. So basically after the orbiters used it all up, the propellants in the external tank, the shuttle, basically it's calculated so that it uses that, and by the time it's used that, it is at its maximum velocity. They drop away, it's not being held down by the atmosphere of Earth anymore, and yeah, so then there's a little bit of fuel left, and the maneuvering engines, which are all over the place, so the maneuvering rockets are able to direct it and shuttle and push it around. That made no sense at all. Just write that down. That makes sense. Okay, the orbiter. That's this section here. This is the orbiter. Basically, the people hang out in here, and they fly this like a plane, like a jet. But the majority of it, these four doors here, that is cargo bay area. So that's where stuff is kept. So the winged orbiter carries both the crew and the cargo. It can carry up to 8 people. The orbiter differs from previous spacecraft in that it glides back down. Like all of the rockets before it, they landed with a parachute, and boom, it lands in the ocean. Then someone goes and gets it. This one is guided and landed on the runway, just like an ordinary jet plane. So the whole point of it was to make it cheaper, and it never really achieved this. I mean, it did, but it was not. It wasn't cheap to the level that they were going for, and it can be reused as many as 100 times. All right, so here we go. If we watch this take off, you can see it starting to turn, and it will invert. And just after that is where parts fly off, like the solid booster rockets. So during liftoff, basically the spacecraft has to overcome the force of gravity. That's why it needs the booster rockets. The shuttle takes off vertically, so it travels against the force of gravity. It just goes straight up. It needs to carry a lot of fuel so that it's able to escape Earth's gravitational field. Now, basically, the more fuel, the more weight it has to carry. So it needs then more force to lift the extra weight. So you want to reduce the weight as much as possible. This is where the booster rockets come in. They help it push the extra fuel up. They carry the extra fuel, which allow it to push up the extra weight. So when the space shuttle returns, it lands at an angle aided at an angle which you'll see in the next diagram, aided by wings like a jet plane does. The atmosphere is actually used as a retarding force, and what that means is it's used to slow it down. Retard the motion means to slow it down, resulting from aerodynamic drag. So that's pretty cool. And basically, on re-entry, the shuttle no longer has the excess weight, so it's actually much easier to steer. And the fuel tank, the external tank, it's jettisoned, it's dropped, it's not needed anymore, and it burns up as it tries to re-enter the Earth's atmosphere. Now, you'll actually notice that it's orange. So if we go back here to this previous page, it's orange, and that's rust. What they found was they could use, I think it was half a ton, or just over a ton. They saved just over a ton by not painting it. And if it didn't need to be painted, then they could save up that ton of extra. So it's got a very thin, clear resin over the top of it to stop it from rusting further. But that is rusted iron on the tank. All right, so we go back here. Boom, 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 boom. Now, as the shuttle glides into land, it needs very small amount of fuel, but it does need a very long runway, and that's one thing that sets it apart. So we say it lands like a jet, but it needs a massively long runway, whereas the other ones, rockets just parachute down. Okay, so this is the shuttle sequence, and what I will do is I will click on this one. So this is the shuttle sequence. So first, it's assembled and built together at Kennedy Space Center. It's moved out onto the launch pad and it lifts off. Now, once it lifts off vertically, and then the shuttle rolls into an inverted position, the solid rocket boosters separate, and then you see they come down, parachute, and they're collected there. And refurbishment here means that it's basically refilled with fuel and ready to go. The main orbiter, okay, so it swings back around to an upright position. It continues to fire. Then it loses the external tanks. By the time it loses the external tanks, it's in orbit, okay, and that drops down. So the shuttle can actually stay up in orbit up until 30 days. This here is the Hubble Space Telescope. So once it's done its orbiting and it's connected with the space station, launched Hubble, whatever it's doing, it can then return to Earth. So return maneuvers are initiated. What this means is that it fires, so the reason it keeps going around the Earth is because of how fast it's going. So it fires retro firing, which means it fires rockets backwards against the direction that it's going, and this slows it down. Once it slows down, it no longer has that momentum to swing it past the Earth again. It starts to fall down. Now, it then falls, where's my mouse? It then falls, but with an angled position. And the reason it does this is to slow it down. If it rocketed down straight, it would be aerodynamic and just boom, straight through. So what it does is it angles up like this, and it means it hits the atmosphere like a sail and it glides down, causing intense heat to fire right here on the base of it. And that's where a lot of its heat shielding is. A lot of its heat shielding is up around the nose here and on the base. So it guides like this to slow down. And it slows down like this because the base of it acts as a sail. Whereas if it came straight down like this, it would be super aerodynamic and it would not slow down at all. So it glides into the landing area at the Kennedy Space Center, and then it lands like an airplane. Yeah, and then it's all complete. Everyone goes home, and they refit it out for the next flight. Now if we get rid of our... How do we get rid of this? Alright, we got it. Took a second. Now, let's compare the liftoff and re-entry. Okay, so with liftoff, it has to overcome the force of gravity. With re-entry, it goes with gravity. Extra fuel required for the SRBs and ET, it doesn't need them, they're jettisoned. It has excess weight due to the extra fuel to help it escape the Earth's gravity. This one's much lighter and much more maneuverable, so it's able to land like a jet plane. It has a vertical launch, straight up. It's maneuvered and landed like a jet plane with wings. The atmosphere hinders the launch, so the atmosphere actually causes problems. One of the reasons we need so much fuel. It's also why we don't need so much fuel when we want to leave the moon. And the atmosphere is used as a retarding drag to slow it down on the land-in. So the atmosphere it hinders on liftoff and helps with re-entry. Vertical launch, very large fuel demand. Horizontal landing, low demand on fuel, but extremely long runway required. All right, so here is a website you can start with. Use whatever you want. What I want you to do is I want you to tabulate the materials used in the STS, or the shuttle, and their functions. So for example, there are glass and ceramic tiles, which are used as a heat shield. There is a fiberglass blanket, which is also used as a heat shield, and so forth and so forth. All right, that's it. That was a long one. Thanks for sticking in there.